Hello everyone, my name is Martin Linksfeld and I'm Master Chef in FoggyKitchen.com. In this short video, I will show you how to integrate OCI event service with OCI functions. All of that will be done with the help of Terraform code crafted for this purpose. One thing more, if you are new to this channel, I really encourage you to subscribe it. I hope you will find it useful for your current and future work. This is our topology diagram. It shows up what is our plan in terms of the architecture and functionality. As you can see, we will have one web server nested in a public subnet. This server will be exposed to public internet via network security group, right? But let's focus on web server's storage. We will have two associated volumes, meaning it will be a boot volume and additional block storage volume, 50 gigs. For both, we will have manual backups, right? Keep in mind one thing. For both block volumes, we'll have associated tags, right? Our plan is to apply those tags on backup resources. So the idea is simple. We have defined tags for volume and volume backup in sync. For the purpose, we will use OCI event, right? Event service. We'll create a rule which will catch the event for each finished backup, and for that backup, a predefined function will be triggered, right? And this function will make the magic for updating the tags for each backup resource. So the tags will be copied from the corresponding volume, which is visible in a JSON of the event. Okay, let me show you now the function code written in Python. I guess it will be very easy to understand.
This is our function, and this file includes JSON file, which will be produced by OCI Cloud Events for create boot volume backup and event, right? As you can see here, right? And this data will be sent to our function. As you can see in a data substructure, right? We can find here two things which are extremely necessary. First of all, OCID of our boot volume backup, right? And additionally, in additional details, we will have OCID of our boot volume, which has been backed up, right? And this data, as I have said, will be sent to our function, which is encoded here in funds.py file. Okay, the main routine is coded in this handler function, right? And what do we have here? Context, CTX, and data input variables, right? CTX, so context, will help to return value in the form of the output JSON, right? Data will include this JSON file, which I have shown you here, right? This JSON which is produced by event service, right? So our function will use the signer and especially get resource principal signer function, but I will explain it a little bit later. But to make this story short, in a Terraform code, I will create dynamic group and associated policy, which will make our function authorized to access other OCI resources in the same compartment. Okay, we have created some additional subroutine here, which is called do, right? And let's analyze what will happen next. First of all, from this data, we need to extract the JSON, and it happens here. And then we need to, we need to access our OCID of boot volume backup and boot volume itself, right? And for that purpose, we will use two variables, right? Then we will create block storage client, which will be signed with the signer. And this block storage client will be used to, first of all, to get boot volume data, right? And then to update boot volume backup with this data, and additionally, which is important, with defined tags. So the tags will be copied from our boot volume into our boot volume backup. And that is mostly all what will be done by this function. And now we can move to Terraform code.
Okay guys, here is my code, my repository for this video recording. And let me start with the web server, which will be built. For this particular web server, we'll have additional block volume, 50 gigs, which I have mentioned before. Also, we'll have for this server some boot volume, right? It is not visible here, but it will be built, with the server as an attachment. Okay, and that is the first thing. Of course, this particular web server is nested in some public subnet, which is a part of the bigger VCN, right? And of course, we have some security groups, route rules, and other details. But let me show you something additional. First of all, we will create the functions, right? Before creating functions, first we need to create the function application, right? So this is a resource which is called OCI functions application. And then we need to prepare our functions, and we need to build them, upload them directly to our registry, and then provision it with two resources, right? One for boot volume, another one for block volume, right? But let me first go to FN setup, where we'll have null resource, the special provisioner, which will do the magic. What this provisioner will do? Of course, first of all, FN app should be built before, right? And then we'll have a local exec, and this local exec will log in from Docker CLI perspective into our registry, which is in our OCI. Next, we will build the function, the first function for boot volume, and then we need to do some kind of a magic to tag our image with the proper tagging for our OCI registry. The same for another function as well, but then we will have Docker push, which will push the image directly to our registry, right? The same procedure will be repeated for another function, block volume function, right? So as I can see here, we have fn build, again tagging with the Docker CLI, tagging for our registry, and ultimately Docker push. After that, we can expect that in our registry, two images will be registered, and then our function can, let's say, utilize this image, right? And where we are referencing image here, right? So our function, which has some name, will use the image which is stored in our registry, right? Function will be built. It will consume 256 megabytes, and second one will reference another image, right? And we can move further. Okay, so we have functions, right? We have web server, as I have mentioned before, right? But how to connect all of that dots here? So we have this event services, which is available in OCI, and event services has been prepared in an event underscore services.tf file. So what do we have here? First of all, we have OCI event rule for our boot volume, right? And how this rule will work. First of all, we will have action, right? Function as a service is an action type, is enabled. And of course, we have some kind of a description here for this trigger. And we have here interpolation to our function, which has been built a few seconds ago, right? And of course, we need to have some kind of a condition which will trigger this action, right? So the event which will trigger this action is creation of the boot volume backup and the finished, which means end of the backup. And this event will trigger the action which is defined here. On the other hand, we have another event rule which is related to our block volume. And again, we have a condition, right? Create volume backup, which will be ended, right? And then another function will be called. Okay, we are nearby the finished of our code review, but still, we need to explore simple thing. We are copying tagging information, right? But where is tagging in this code? So let me show you tags.tf, and as you can see, we are creating a tag namespace and two tags inside this namespace which will be utilized, right? And these resources will be used for our volumes, for example. So as you can see, for this 50 gigs volume, we will have defined stock, which will be then copied into the backup, right? By the function. The same for the server, right? So our server has also defined tags, which are populated here. And that is all in case of the tagging, but we have yet another thing to discuss. Okay, so policies, right? All of that functions execution will not work without proper policies. And we have here three policies and one dynamic group, and let me explore that a little bit. So first of all, we need to allow function as a service to read our repositories, our Docker repositories in OCI, where we have uploaded our images, right? Next, we need to also allow function as a service of our functions to utilize virtual network family in particular compartment. It's very simple. If you go directly to our FNAP, you see that this FNAP is nested in particular subnet. So this FNAP should be able to, use the network, which is here, right? So let me return back to policies again. We have also a special dynamic group. And the question is why we are using dynamic groups and then the special policy for that dynamic group. Mostly because our function, as we see, will interact with other OCI resources, right? Let me return back to the function just to show you. right? So we will, from the function perspective, we will go to block storage client, right? And we will interact with our block volume and boot volume backup or boot volume itself. So our function should be capable to should be authorized, right, to our OCI resources. And for that reason, we will build this dynamic group, right? So in this dynamic group, we will have a matching rule, right? So function, so resource type fn func, right, will interact with resources in this particular compartment, right? And of course, then we'll create this policy which allow this dynamic group, right, to manage all of the resources in this compartment. And that is mostly all I would like to show in Terraform code. And now we'll go directly to console, OCI console, and OCI Cloud Shell to show you how this stuff is working. Okay, now I am in my OCI console. I have started my Cloud Shell, and in this Cloud Shell I'm currently in a proper directory which consists the copy, the clone of my repository. And now I will run Terraform plan just to see what is planned for me. And as you can see, there is a plan to create 27 resources. First of all, my plan here is to run the backups, manual backups, after everything will be properly configured. But at the first time, they won't be created, right? That's why I'm changing the content of the file. And now I expect it will be 25 resources. So let me run Terraform apply, and we will see what kind of resources will be built. Of course, it will take some time, so probably I will pause in some moment in time, but before, let me show you. So right now I'm building the image, and this image will be, after successful build, will be uploaded with Docker push into our repository. So yeah, let me change it a little bit, and I will go directly to registry, to our repository. Right now it's empty, but I expect it will be sooner or later uploaded into our repository, right? Our Docker repository. Okay, it's still in the middle, so yeah, I think I will wait a couple of seconds, and if it's not ready, I will just pause. So yeah, I will pause here for a moment. So as you can see, our code has been pushed. So let me refresh it. Okay, and I will go again to the repository. Okay, so for the first function, we have the image, which has been created by the code. I guess the second one is still in the middle, maybe. No, it's already pushed. So both function has been pushed. I mean the images, and we have an error, which is unexpected. But let me rerun the Terraform apply, because probably something has been messed up in the middle. And right now we can see, right, okay, so what has been problematic? Let me check it. Tags. So namespace is not found, right? Anyhow, let me verify that from tagging perspective. So tag next namespaces. Okay. Okay, so yeah, ultimately it was successful, right? So it was some temporal problem, and now we are building the web server, right, and the block volume. So let me go to the web server, right, just to verify the state. Still provisioning. And yeah, so this web server, I guess, will be target block volumes. Okay, the process is still ongoing, but meanwhile we will go directly to our functions, right? So let me scroll, and now I will go to developer services and functions, right? So as you can see, we have fn up, right? We have two functions which has been built successfully, and let's say we'll choose this one. The function has not been started so far, what we can see in the metrics. And yeah, and another thing very important is event service, right? So let me make it smaller, and yeah, and we have two triggers, right? So we have one trigger for boot volume, and as we click here we can see the rule, right? So we have a condition, create volume backup end, and for this condition this JSON file will be created. This is equivalent what I have shown you a few minutes ago in my Sublime text, and this JSON file will be sent where to function, right, which is associated as an action. The same, or let's say pretty the same, we have for volume backup, right? So we have a rule for this trigger, and we have create volume backup end, again some JSON, right, and with data volume, right, and a volume backup, and it will be sent to the function, which is here. Okay, looks like ready. So let me return back to our Cloud Shell. Okay, everything is fine. So the machine should be there. So let me go to the compute, the web server, and verify tagging information. So for boot volume, right, we have a boot volume here, and this boot volume should have tagging which has been decided in a Terraform. Oops, too much. Okay, so tagging, right, tagging is okay, and let's return back to compute. Okay, and I will show you for this attached volume, which is here. And for this attached volume we should have also tagging, right? Okay, block volume and tagging. Okay, so tagging, defined tags are here, right? And now we can, right, we can change this web server volume backup file, and we will create two resources for manual backup of boot volume and block volume, right? So now when we run Terraform apply, it will create two resources, right? Manual resources, two resources. 50 gigs volume backup, full for block volume and full backup for boot volume, right? Both manual. Clicking, typing yes, and let's go to our okay, instance, and to block volume, right? Maybe boot volume first, okay? And yeah, and block boot volume and boot volume backup, right? And as you can see, it's in the middle. We cannot verify the tagging information because it's in the middle, but we can expect it will be sooner or later ready. So let me pause for a moment. Okay, the backup has been finished after 5 minutes and 40 seconds. And let me verify the tagging. So view tags, you see the tags has been copied, right? And how all of that has happened, let's go first to our event service just to verify if the trigger has fired, right, for a boot volume. And I expect we will see this small dot. So trigger has been fired, and this trigger fired the function, right? And let's verify that also from function perspective, right? So function is here, and let me go directly to the boot volume function, and yeah, it's here. This function has been executed. So we have that in the invocation, no error, and this is what we have seen, right? Docs has been copied. Let's also verify that from the compute from block volume perspective. So I will return back to our machine, and I will go to attached block volume. And for this block volume, I will verify also the backup, right? And we have this this backup, right? Let's verify tagging information has been copied. So let us check that stuff from our events perspective. So this time we will go to our trigger for block volume. Let me verify if it has been started, right? Fast function as a service successfully. And let us verify metrics for the particular function which is responsible for block volume, right? So I'm here in functions, I'm scrolling down 2 functions up, and I'm going to block volume function, and yep, it's here. It has been executed, no errors, and that's fine. That's why all of that works. And that concludes this recording. And of course, I will destroy this infrastructure afterwards, and you can do it as well from your Cloud Shell in your tenancy. Thank you very much, and see you soon.